Very good morning, everyone. Myself, Dr. Satish Hande, Associate Professor, Department of Mathematics, KLS VDIT, Aliad. So, today's topic is eigenvalue and eigenvector and the properties of eigenvalues and eigenvector. What do I mean by similar matrix and what is diagonalizable matrix, which is covered under the subject name Calculus and Linear Algebra with the subject code 18MAT11. So, overview, as I said, in this topic we are going to cover what do I mean by eigenvalue and eigenvector. Second, some properties of eigenvalue and eigenvector. What do I mean by similar matrix? And lastly, what do I mean by diagonalizable matrix? Next, what is eigenvalue and eigenvector? Generally, when we multiply a matrix by a vector, or when a matrix multiplies a vector in general, the magnitude and direction of the vector will change. Now, there are some special vector where only their magnitude is changed when they are multiplied by a matrix. Now, these special vectors are called as eigenvectors. The value by which the length changes is associated eigenvalue. We say that x is the eigenvalue of a, capital A, if ax is equals to lambda x, where lambda is called the associated eigenvalue. Now, some properties: if lambda 1, lambda 2 and so on up to lambda n are the distinct eigenvalues of the matrix, then the corresponding eigenvalue vectors e1, e2 and so on up to en are linearly independent. What do I mean by linearly independent? Then one eigenvector cannot be obtained from the other eigenvector. Secondly, if e1 is eigenvector of a matrix corresponding to the eigenvalue lambda 1, then any non-zero scalar multiple of e1 is also an eigenvector with eigenvalue lambda 1. Third, a real symmetric square matrix has a real eigenvalue with orthogonal eigenvectors. Next, fourth property, the equation ax is equals to lambda x can also be written as a minus lambda I into x equals to 0, where lambda is the eigenvalue of a if and only if equation 1 has non-trivial solution, means it is non-zero solution. Then next one, that is equation 1 has non-trivial solution if and only if a minus lambda I is singular, or equivalently, that is determinant of a minus lambda I must be equals to 0. When we are equating it to 0, we are getting a equation which is called as a characteristic equation. And if the equation 2, that is determinant of a minus lambda I equals to 0 is expanded, we obtain an nth degree polynomial in lambda, which is called as characteristic polynomial. Now next, what do I mean by similar matrices? A matrix B, capital B, is said to be similar to the matrix capital A if there exists a non-singular matrix S such that B is equals to S inverse AS. Now, non-singular matrix means determinant value is not equals to 0. If B is equals to S inverse AS, then we call it as a B, the matrix B is similar to matrix A. Secondly, for n cross n matrix, capital A and capital B, if A is similar to B, then the two matrices both have the same characteristic polynomial and consequently both have same eigenvalues. Lastly, what do I mean by diagonalizable matrix? An n cross n matrix capital A is said to be diagonalizable matrix if there exists a non-singular matrix capital X and a diagonalizable matrix D such that X inverse AX is equals to capital D. That means D is equals to X inverse AX. D stands for diagonalizable matrix. We say that X diagonalizes A, where X is a matrix of eigenvalues and the eigenvectors. With this, I conclude today's session. So we have covered what do I mean by eigenvalue, eigenvector, then characteristic polynomial, then similar matrix and diagonalizable matrix. Thank you.